Are doing well. So today our topic is ionic bonding, and that's actually one of the easier topics for O levels or IGCSE chemistry. And what it deals with is basically how metals do the reaction when there is another non-metal present. So basically the idea is that they want to have a complete octet in the last shell, and they would want to go for 0 or 8 if that is the case. And to do that, metals always try to lose electrons. We talked about it last time that metals lose electrons and they just throw them out there, and there's a cloud or sea of delocalized electrons that's around them. And that is what allows them to actually form metallic bonding. So there's rows of cations and there's a lot of electrons moving around. Now, what happens if when they throw those electrons out, there's something to gain them as well. And that is how ionic bond forms. Now again, I would like to reiterate that in any kind of bonding that we see, there must be a positive thing, there must be a negative thing, and there must be strong force of attraction between those two things, which we call ionic bond. So as we go along, we should be able to identify what that positive thing is, what that negative thing is in the case of ionic bonding. So ionic bond forms when there is a transfer of electrons. So atoms lose or gain electrons to become ions. So that's a new term here. And if you recall, I told you that there are particles, and those particles were the general word that we have been using. And today we are going to move on from atoms because that's the most basic one and it's a neutral one. And we're moving on to a new particle which is called ion. So ion is a new particle that we have, and basically it is the particle in which protons and electrons are not equal in number. Now, how does that work? We already know that proton is inside the atom, it's deep hidden inside the nucleus. So there's technically no easy way for proton to get out of that nucleus and go out. But electrons can readily be moved around, they can be added, they can be removed from atoms. So basically, ions form when there's a gain or loss of electrons. And that's what ions are. So if you talk about protons and electrons, then atom has those numbers equal, and protons, when they're not equal to electrons, they form ions. Now there's two kinds of ions because there's two cases. One, you have less electrons than protons, and one you have more electrons than protons. Again, I'm saying more electrons or less electrons because I'm not really talking about protons coming in or going out of any atom, because that's pretty much quite difficult to do. There are some cases in which that happens, but we won't get to that for now. So if electrons are more, we call that anion, and if electrons are less, we call that cation. And the difference is that in one of them, anion, there's more electrons, so electrons are more than protons, which means it has a negative charge. And in cations, there's more protons. Actually, there's less electrons than protons, so it's a positive charge. So those are the cases that we have for different ions. Now, there's only two categories of ions, positive and negative. Now, how exactly does this work? Now, I'm going to introduce a new term here, and that's called redox. Now, usually, if you are somebody who has been taking O-levels classes, you might not have seen this term while studying ionic bonding, but they're very closely related. Redox is basically an acronym of reduction and oxidation. Now, reduction is loss of electrons. So gain of electrons, my bad. Oxidation is loss of electrons, and reduction is gain of electrons. When something gains an electron or more electrons, it is reduced. So one way to remember this is to just take these first words here, OIL, RIG, and that gives me oil rig. Oxidation is loss, reduction is gain when it comes to electrons. Now, basically atoms, they're really good at losing electrons because they have 1, 2, or 3, especially the electron that we are going to talk about. They have just those 3, maximum 3 electrons in the last shell. So they're really good at losing it, so they become 0. And nonmetals, they're really good at gaining them, and they become 8 in the last shell. So they try to do this. metals try to oxidize and non-metals try to reduce. If a metal oxidizes really fast or it is really good at it, we say that it's a more reactive metal. And if a non-metal is really good at accepting electrons or taking electrons, we say that that is a more reactive non-metal. So that's the case. Non-metals, when they gain electron, they're more reactive. Metals, when they lose electrons in general, they are considered more reactive. Now, if you look in the periodic table, there's a very neat way of knowing this. Down the group, if you go, then metals will become bigger and bigger in size, metal atoms, which means that they can easily lose that last electron because it's going further away from them. So it becomes easier to oxidize, it becomes easier to lose electrons. So that is why metals become more reactive if you go downwards. Non-metals, if you go downwards, they become less reactive. But the reason is same. They're still getting bigger and bigger, just like metals, but they want to gain electrons. So it's difficult to gain an electron. It takes more energy to do it if the electron is very far away. That is why when metals, you go down the group, metals become more reactive. Potassium will be more reactive than sodium. But non-metals, if you go down the group, they become less reactive. And for example, chlorine, which is in group 7, will be more reactive than bromine because chlorine is a smaller atom, it gains electrons. Alright, so it gains electrons, becomes anion, metals lose electrons, become cation. Alright, so that is how we get ions, and those ions, so if an atom loses, it becomes a positive ion, that's a cation, positive charge. If an atom gains electron, it becomes a negative ion, negative charge. Now, the number of how many electrons it loses, that number should be kind of related to its group number in the periodic table. Why? Because the periodic table tells us the group number based on how many valence electrons it has. So group number in the periodic table, group number is related, in fact it is equal to the number of valence electrons, which means that if it's 1, 2 or 3, that means they want to get to 0 and they will lose 1, 2 or 3 electrons. And if it is 4, 5, 6, 7, they want to get to 8 and they will gain that many electrons. Like 5 would gain 3 electrons, 6 will gain 2 electrons, 7 will gain 1 electron to get to 8. And 8, those that are already in group 8, they won't do anything. They'll just need 0 more electrons. So that's why they are unreactive. So you see, understanding redox and understanding how they form ions helps us understand how things are arranged in the periodic table and how those groups exist the way they do. We call the columns groups. Alright, so now the number of valence electrons, and you just have to see, is it closer to 0 or 8? If it is closer to 0, it forms a positive ion. If it's closer to 8, it forms a negative ion. Let's take a simple example. Let's say we have magnesium, and magnesium is 2, 8, 2. And we have oxygen, an oxygen atom, that's what I'm talking about. Oxygen has 2, 6. Now that is basically the configuration, how the electrons are arranged. Now magnesium has 2 in the last shell. It's in group 2, so it would like to go to 0, right? Because 0 is closer to 2 than 8. So it loses these 2 electrons. We say that magnesium atom loses 2 electrons. Another way of saying the same thing is that instead of saying magnesium atom loses 2 electrons, we can say that magnesium atom becomes or divides into magnesium ion with a positive 2 charge and 2 electrons. Now this thing, writing sentences, it can be cumbersome. Different people might have different handwriting. It's difficult to read sometimes. So we have equations to represent it. So magnesium is just Mg atom, and that changes to, the word becomes is now an arrow. Magnesium positive 2, now I can write it as positive 2 or I can write it as 2 positive, it's the same thing. And, so instead of and I have a plus, 2 electrons. So basically the magnesium atom was whole and now it is separated into magnesium ion and 2 electrons. Where do those 2 electrons go? Metals have already lost electrons. Metals have metallic bonding, they already lose electrons. Where do those electrons go? They go to oxygen. Because notice oxygen is at 6. It needs 2 more electrons if it wants to get to 8. So it gets 2 electrons. So we say that oxygen atom In fact, each oxygen atom gains 2 electrons to become oxide ion. Now the name changes. This is oxide. Okay. So oxygen atom gains 2 electrons to become oxide. Now this thing can be translated to an equation by just saying oxygen changes to oxide ion. But where are the electrons? So notice that become is after the electrons. So that's why electrons are before the becomes, the arrow. So 2 electrons with oxygen atom will become oxide ion, and magnesium will split into magnesium ion and 2 electrons. And that is how you get these 2 ions. Now, of course, when they do this, there's going to be a lot of change in their structure. And we know that change. So here is an idea. This is a diagram to represent what magnesium atom should look like. Yeah. So this is the configuration of magnesium atom. But when it lost 2 electrons, then it would become like this. So we represent it through a diagram which is like this. So notice the difference. First of all, magnesium atom and magnesium ion, they both have 12 protons. Protons are still the same. Now it depends on what isotope it is to figure out how many neutrons it has. But the electrons are 2, 8 and 2, that is 12 electrons. But in the case of magnesium ion, the last shell is now empty. Now, if you're doing it in the exam, you can draw an empty shell, or you can just lose that shell altogether. You can just draw 2 shells, and that's perfectly fine. Both cases will let you get that mark. Now, the charge should be shown with a square bracket, just like we have over here. Now, similar thing happens with oxide, that when oxygen gains 2 electrons, its atomic structure changes. So if you look at oxide, then oxygen is like this. It has 2 and 6, that's a configuration, and oxygen has 8 electrons. Again, how many neutrons it has depends on what isotope it is. But when it changes to oxide ion, it basically changes the configuration, and this is what you get. So you can clearly see that now you have 2 more electrons. And notice that these are crosses, these 2 symbols. Those crosses are basically showing that we've got those electrons from another atom. And in this case, it was magnesium. And now what happens? Now comes the fun part, that you have magnesium ions, you have oxide ions, one is positive, one is negative. They're going to attract. And they attract. They attract so strongly that we have a special word for it. We call it an ionic bond. It is so strong that this thing completely changes its behavior now, and it has changed, it has transformed these things into a completely new thing. Oxygen was a gas, magnesium was a soft metal, not as soft as group 1, but still a soft metal. And suddenly magnesium oxide is made, and that magnesium oxide is such a strong solid that we can use it to line up the furnaces with so much high temperature that bake so many things. We put magnesium oxide inside so that the furnace's body remains safe, and this absorbs all the heat and doesn't change anything about it. So it has completely transformed. This simple process of losing 2 electrons for magnesium and gaining 2 electrons for oxygen has completely transformed the way it behaves, the way its properties are. And in fact, not just change it, it has also changed its structure. So how does the structure work? Basically, there is going to be, obviously, as you know, positive and negative attract. So the positive thing is cation, the negative thing is anion. So what is ionic bond? Ionic bond is strong force of attraction between cations and anions. So remember, I told you that you need to have positive and negative charges to get a strong bond, and in this case you have cations and anions. In the case of metals, you had positive ions, you had negative electrons. So you have electrons that are negative and positive ions, and they attract to get metallic bonding. And now you have positive ions and negative ions that have now the ionic bond. Now, of course, how they form is a completely different thing. How they form is that it is formed through or by transfer of electron. So usually we define ionic bond as that, but remember, ionic bond is not that it has transferred electrons and that's how it's made. That's not what ionic bond is. Ionic bond is the strong force of attraction that positive ions and negative ions have on each other. How it's formed is its history. Alright? So that's the thing. Now that you have these ions and they're like that, we need to know how it forms if you have a different number. For example, if sodium were to react with the same oxygen, then here's the thing. Sodium has one electron in the last shell, and now I'm only going to draw the last shell so that the inner shells, you see, they don't have any part to play in bonding. So what happens is that sodium, it has its last shell. Sodium is 281. So that's what happens. That's 281. So it just loses one electron. But oxygen is still 26. It needs two more electrons, right? So what's going to happen? We need a way that oxygen gets its two electrons and sodium loses its one electron. So what does that mean? That means we give two electrons to oxygen and we get them from sodium, but not the same sodium, from multiple sodiums. So basically, we take one from one sodium and one from another sodium because there's no shortage of electrons here. There's plenty of atoms to go around. So two sodium atoms lose an electron each. Each oxygen atom gains two electrons. Now, if you're in grade 11, then, or whatever year you are, if you're in the last year, you must have studied LCM or HCF in mathematics. Now, LCM is a very easy way of understanding how this works. For example, if I told you about aluminum and oxygen, then aluminum is 283 and oxygen is 26. It might be difficult to understand that, wait a minute, how many is aluminum losing? It's losing 3. How many is oxygen gaining? It's losing 2. So what exactly is the balance? How do they figure it out? How many of aluminum do I need and how many of oxygen do I need? You can just take the LCM. So oxygen needs 2, aluminum needs 3 to lose. So 3 and 2, that's an LCM of 6. So how do you make 6 from aluminum? You take 2 aluminum. So 2 aluminum lose 3 electrons each. And again, you need 2 electrons for oxygen. So 3 oxygen gain 2 electrons each. So that's a way you can easily figure out how much charge I need, because charge is going to be your LCM. And you can easily figure out how many atoms are involved. In fact, there's a question in the exam that's usually asked about how describe in terms of electrons how aluminum reacts with oxygen. That is one way that they might ask this question. Now you might say that's all good, but I don't want to get trapped into this. I want a shorter way, and the shorter way exists. Just take whatever ion you have and think about that. So for example, sodium forms positive 1 ion and oxide is O with negative 2. Now the method to combine them, I call it, and again this is a term that I've made myself, I haven't read it in the book, but it works. I call it ratio flip. So here's what you do. You take the charges. On sodium you have 1, on oxide you have 2. Just write them. Sodium, oxide. So sodium is 1, oxygen is 2, flip them. Alright, so take the 1 charge on sodium, take the 2 charge on oxygen, flip them. And when you flip them, the 2 comes here, 1 goes there. You don't really need to write 1. And that's your formula. And how do you name this thing? Just name the ion. So this is sodium ion, that's oxide ion. So my formula is sodium oxide. Let's do it with aluminum. Let's see if it works. So aluminum forms aluminum with plus 3 because it has 3 in the last shell. It's going to lose them, get to 0. Oxygen forms oxide, which is negative 2. So take the numbers 3 and 2. Now flip them. Now when you flip it, it becomes 2 and 3, right? So Al2O3. Yeah, that's the formula of aluminum oxide. How do I know it's aluminum oxide? It's aluminum ion and oxide ion, and that's it. That's all I need to know, the formula. Now, is it possible that I can get these charges for other things? Of course it is. Of course, there are atoms that lose multiple kinds of them. For example, we call them transition metals. So transition metals, they lose multiple different number of electrons based on where they are. So iron, for example, and I'm going to give you a list of things that you need to remember. So iron loses 2, sometimes it loses 3. So when it loses 2, it changes sign to iron plus 2. And when it loses 3, it forms plus 3. Now the interesting thing is that iron 2, you can check it, that is it iron 2 or iron 3, by just adding a hydroxide, a soluble hydroxide like potassium hydroxide, sodium hydroxide, ammonium hydroxide. Anything that has a hydroxide and reacts with iron, it will create iron hydroxide. Now if it is with 2, it will be green. And if it is with 3, it will be red. I'm talking about iron, the hydroxide that it forms. So based on this, you can easily see that it has a different color. Now there is a very good sound explanation of why this is giving a red color and why that is giving a green color. And it has to do with frequency of energy, frequency of light, electrons configuration, and so many things. But we'll see to that later on in A levels. All right, now what about copper? Copper is also a very useful transition metal. So copper goes copper 1 and copper 2. And copper 2, when it reacts, when you check it in the lab, it goes blue and this one goes red. But in O levels or IGCSE, we don't talk about it. We just focus on the blue one, copper 2. But of course, what's the name? This one is called iron 2. Why 2? Because iron has the 2 charge on it. So remember, it's not telling me how many iron I have. It's just telling me that it is iron 2 with a 2 charge. Similarly, this is iron 3 and that is iron with a plus 3 charge. It doesn't really have to be charged every time. Sometimes we also use oxidation state, which is something we'll talk about later on. Now, that one will be called copper 1 or copper 2. Similarly, there's chromium in our syllabus and chromium 3+, and that is green when you test it in the lab using a hydroxide. Now, I'm not talking about the color of the ion. I'm saying its hydroxide is this color. Now, here's the thing. Not all transition metals that you might feel that are transition metal are actually transition metals. There are 2 in our syllabus, in fact 3 now, that seem like transition metals, but as far as we are concerned, they don't show any of those properties. So we'll talk about them. So for example, there is zinc. Now zinc is in the transition metal block, but zinc is always going to form +2. And its hydroxide will be white or colorless. Similarly, we have scandium, which is Sc, and that goes scandium 3. But we don't say it's scandium 3, we just say it's scandium ion because it's always going to be +3. So this is zinc, not zinc 2, and that is scandium, not scandium 2. Now there is another third case, which is a transition metal, but we still treat it like it's not in O levels and IGCSE. Again, there's a reason for that, but we don't have to get into that. And that is silver. Silver is Ag, which forms Ag+1, but we don't say it's silver 1. We just say it's silver ion. Okay, so that's important to know. Whenever you're naming them, you have to name them like that. Okay, so good enough. We have the charges, we know the method. We know the method of forming ions. We know how many electrons are lost or gained. And we know that what ionic bond is and what it's formed between. All right, so now that we know all that, let's see what ionic bonds or ionic compounds do. So here's the thing. Ionic compounds are part of something that is very similar to what we studied in metals. In metals, we used the word lattice. We said that there's a lattice of cations and there's so many electrons floating around. There's a sea of electrons. Now, in the case of ionic compounds, we also have a lattice, and this lattice is called ionic bond. In my regular session that happens at 4 o'clock, I usually show a 3-dimensional diagram of what ionic bond is and all that, but I can't show it over here because it's proprietary and I can't use it on a public platform like YouTube. But that ionic bond does look something like this one. So if I can take this picture, yep. Okay, so yeah, if you look over here, what's happening here is that this is a structure, a basic structure of sodium and chloride. You have sodium ion, which are shown in red, and you have chloride ions, which are shown in green. Now, if you notice what's happening, every sodium ion that you have is surrounded by chloride on all sides. Now, let's take this pencil for example. How many dimensions does this have? So there's front, back, right, left, up, and down. So just like that, you can surround every ion into these 6 directions, provided the ratio is 1:1. If it is more than that, there are other ways of arranging, and I think there are 9 different ways of arranging them, or 6, I'm not sure. But we form different crystals based on this. Now, this is also a lattice. Wherever you have a regular structure, that's a giant lattice. So this is called a giant ionic lattice, and all ionic compounds exist as that, which means they all have high melting point. Again, let's look at these properties. You have positive ions, negative ions surrounding each other completely from all sides and having very strong force in there. So what's going to happen? They are going to have high melting points. Because of giant lattice and strong forces, it is going to be really difficult to break that force. So they're going to have high melting point because of it. Again, the reason why this happens is because they have strong electrostatic, or just say force of attraction. Now this strong force of attraction, what does it mean? Number one, it means they're going to be hard. They're going to be rigid. They're going to be fixed in their place. It's very difficult to move them. And if you try to move them, you'll just break it. Why? Because one positive repels the other positive. So right now they're arranged as positive surrounding negative. But the moment you push it a little bit, you nudge it a little bit, and the positive might come in contact with another positive, which will repel it. And that means it will throw it out. It will break it. And that's why these things are brittle. They break really easily. And then they're going to have high melting point because of this, because it's going to take a lot of energy to break all of this. All right, fair enough. But these ions are fixed in place, right? Yeah, they are. So ions have fixed placed. So that means that ions are obviously held by strong forces in a lattice. So that means that no electricity conduction. I'm just going to call it ECT. All right. So no conduction of electricity. In fact, they're really bad conductor. We can use them in electric furnaces because they won't conduct electricity and they will absorb all the heat. So win-win. Now, no conduction of electricity, right? But the moment electricity, not electrons. Now, the moment I break the lattice, all I have to do is break the lattice. And now ions are free. They're completely free to move anywhere they want. So what happens is that you break the lattice. And when do you break the lattice? You melt it. So if they're a liquid, if the substance becomes a liquid, then ions are free if in liquid, aqueous, or gaseous state. All right. So now there's a good conduction going to happen. They're going to conduct electricity. Okay, they're good conductors now. So if you break the lattice down, you can dissolve it in water. Not all ionic compounds dissolve, but many do. So you can dissolve them in water and they will conduct. You can boil it and it will conduct. You can make a liquid out of it, melt it, and it will conduct because it has free ions, so many of them, all moving around and conducting electricity because ions are ready to move now. All right, so just take an idea that this is a solid. So for example, in this case, this is a solid and ions are not free, they're held in place. And this is a liquid, as you can see. Now, where do ions move? They move towards positive and negative terminals. So if you have a negative side and you have a positive side and you get a solid thing in there, ions are not going to move. But you take a negative side and you have a positive side and you melt it, all the cations are going to rush towards the negative side and all the anions are going to rush towards the positive side. And that is why ionic compounds, it's a very important point, ionic compounds decompose when they conduct electricity. So we use that process for extracting different metals from it, and we will study about it. That's called electrolysis, and we can also use this idea to produce uh, electricity as well, for example in batteries. Yeah, so that's the idea of ionic bonding, how ions are, what redox reactions have to do with them, and how do you write formulas of ionic compounds, what their properties are like. So make sure that you review this. I will share the notes with you in the WhatsApp group as well. But for now, I'm going to give you a quiz. So let's attempt the quiz and I will share the recording with you later on. All right, so thank you so much for joining in. Thank you so much for, I really enjoyed your questions. Abdullah Huda, Hashem. Yeah, I can totally understand that chemistry can be difficult, yes, but I'm here to help you out. And inshallah, I'll definitely help you out until the June exams, and hopefully after that for your friends or your juniors. So I totally understand that. I hope you get well soon. I'm so sorry you had an accident. I hope you get well soon. Don't worry, things do get better after a while. Hello, Sharik. It's good to see you. Guys, Sharik has been one of my, like, amongst the most brilliant students I've had the pleasure to teach. So, yeah, it's good to see you. And hello, Abdullah. Hello, Muhammad. Hello, Musa. Yeah, it's a pleasure seeing you here. In fact, pleasure seeing you all here. Yeah, so thank you so much for attending. Make sure that you invite your friends if you like it, and make sure that you subscribe this so that I can continue to help you out with the remaining topics. Tomorrow we'll talk about covalent bonding. I'm sharing the link here for the quiz. Attempt it, and inshallah, I'll see you in the next class. Any questions, let me know. I'm good. Yeah, I'm good. Thank you. Thank you. All right. I'll see you. Take care. Allah Hafiz.